So now we're going to look into another example, and this time we are going to pass in a string class type, whereas in our previous example we have looked into we have passed in a class type of integer rather than a primitive type of int. So you may know, if you have previously worked with strings and especially strings in Java programming language, that strings are a class by themselves. They're not a primitive type, but you don't have to load the string class inside your ID or inside your program. It will be given at compile time, and if you use string inside your generic class, then you should also pass in string values when you're calling an instance of your generic class. So let's have a look. So first we're going to create an object called let's call this generics string, and then we're going to pass in string class type, and this time we're going to call it string gen, and the instance will be generics. Oh, sorry, I actually made a mistake in here, and this should be first example, and this should be the same thing, and first example, and then it's going to be the string class type. Now the interesting part in here is that if you're passing in a string class type, then you won't be able to pass in an integer value or a float value. You have to have a consistency when passing in a string class type with your value that you're going to pass in inside this constructor. So we're going to write, this is a string parameterized type. I guess that's the correct spelling for parameterized. And then what we're going to do is that we're going to call in all the member methods, and we're going to see what they actually return to us. So let's create another variable called string str, and this time we're going to call in strgen, and we're going to get the object, and we're going to store that inside this str string variable. So you may notice that we're doing the same thing, or the process is actually quite similar, although it's not exactly the same thing, because we have used an integer class type, and we have passed an integer value, which is a primitive type of int, inside our generic class, and then we have auto unboxing feature being used inside here so that we can get the value from our generic class or our generic instance, if we put it more precisely, and then when our instance returns, it will actually cast or implicitly convert that integer class type's value into a primitive type, which is an int num variable. And similarly, this is going to go in the same direction, but in here we are actually using a string class, whereas to actually declare the str variable, and then we are also using a string class to take in a value inside our generic class. So all this casting is done implicitly, as I've mentioned earlier. You don't have to worry about them, but we will get some things different when we use different types of class types. So we are going to use two types in here, and then we're going to see how we can bound those, or how we can actually say to our users or people who are going to use our code that you can only use this number of data types inside our generic class. You can't actually use other types of other data types outside the list that we have specified. So let's actually finish with this system out print line, and then second type is we're going to pass in str. This is not the second type, this is the second value, and we are going to call in the str gen, and this time we're going to call in the show type method, and we'll see something interesting after we run this code. I'll show you something different than what I'm showing you right now. So let's run this, and you can see that the first time we were passing in an integer value, and this is being auto boxed inside this generic class using our wrapper class called integer. And then in the second instance, we're creating a generic class, or more precisely, we're creating a generic instance, generic classes instance, and we're passing in a string class type, and this time we're also passing in a string value inside our constructor, and then we are getting that value. We're actually getting that value, and we are storing it inside another variable, and this is actually valid and this is allowed, and so we are printing it out on our console, and you can see that we get the expected value being printed out. And then we call in the show type. Now this is quite interesting. In here is what's happening behind the scene is that the first time we pass in an integer wrapper, it actually understands our class. If we go back here, it actually replaces this t in every place that we have called it, and then it replaces that t with the integer. So when we pass in integer, we can see that the first time we're passing an integer wrapper, then it will replace that t with this integer wrapper class. And in every instance, you will see, or behind the scenes, the compiler will replace those t with integer. And in the second instance, you can actually see that we have a class type of string. So in here, rather than integer, this will then pass in string, and we don't have to do anything inside the class just to make this change. If you had done some form of Java programming before the generics came into the JDK 7 suite, then you would have to have certain code, or you have to have certain understanding on how to cast them, how to pass in, how to create a class that would accommodate all of your integer wrapper, all of your integer values, and also your string values. But when we use generics, we don't have to worry about all this implementation. We can actually generalize, and then our compiler will handle everything for us, at least what we are specifying. So let's put the correct name, and then let's go back. So that was a simple example, and then what I'm going to show you is that, suppose if you want to assign or reassign something like this, num, we have already created a variable in here called num, and then we also have another variable called str, and then we're going to reassign str inside num. So this is actually a problem. The reason why it's a problem, you might consider that it's not a problem from your perspective, because look, we're using the generic class. We're also using the same instances of the generic class. It would have been true that if you have not used, or if you have removed this angle bracket, or it was just like any other class, not a generic class or a parameterized class, it's a different class than you have used previously when you didn't utilize the power of generics. So now what you have in here is that a parameterized type, and this parameterized type is now in control. So this parameterized type is now going to control what you can assign inside that variable and what you cannot assign. Sorry, we're not going to use that. I should be more specific. Rather than using int num, I'm going to use the instance. That's going to make things clear. Okay, now this is an error. You can already see that my compiler is complaining that type mismatch. If you can read that small font, it's actually written that type mismatch cannot convert from generic first class string to generic first class integer, which means that these two types are actually incompatible. Just like I said, this parameter that you are passing inside your class is now in control. Your class is not exactly in control, it's in the back seat. In the driver's seat, it's this integer type, data type, or your wrapper class that's going to determine what you can pass inside your class and what you cannot pass inside your class. So these two are actually different class types. Integer is one class type, whereas string is another. So you cannot necessarily cast in your string into your integer. So that's why it's complaining that there is a type mismatch.